Hello everybody, my name is Debashish Roy. I'm the Senior Technical Trainer at the Indian Cyber Security Solutions, and these are my contact informations in LinkedIn and Twitter in case you want to contact me. Today I'm going to discuss about virtual LANs or VLAN. That is our topic, virtual LAN. Now, what is a LAN? A LAN is a local area network where we see many PCs connected to a common switch, and previously it was bridge or hub. Means it is a single network, or you can say it is a single broadcast domain. Means that, say for example, this is a switch. It is a switch, and all the PCs are connected here. So this is a single broadcast domain. Means this PCA is going to send a packet, a broadcast to PCB. Then what happens? That PCA can view PCB as well as PCB can view PCA. They can access both because they belong to the same broadcast domain or the same LAN. So there is a problem of security also, that every PC can access other, can see the resource. And there is a problem of broadcast also. The number of PC, as the number of PC grows, then you have PCC, and again you just add PCD. Then as the PC grows, the number of broadcast packets increase. So your broadcast domain increases. So we have to segment the broadcast domain in order to maintain our network bandwidth, in order to conserve our bandwidth. For that, VLAN comes. A VLAN or a virtual LAN is a logical grouping of some network devices in the same subnet. What does it mean? See, there are A, B, C, D, 4 PCs, and I want all pieces to be attached to the switch. So what I can do, I can create some logical groupings. It is only logical, remember, not physical. I can create some logical groupings. Say for example, I'm taking these two pieces A and B in a logical group and C and D in another logical group. A and B is inside a group, inside a VLAN, say VLAN 10, and this is a part of VLAN, say VLAN 20. You can give any numbers. So it's a logical grouping, just like work group. As we create work group according to our departments or groups, just like that we create VLANs, and we assign VLAN to each switch port individually. So it is port based VLAN, the port membership based VLAN, should I say. So what happens, that you create logical subnets. Say for example, this is 10.0 subnet and this is 20.0 subnet. So this subnet A, this subnet B, you can say. So the broadcast of this VLAN 10 of this 10.0 subnet cannot go to this VLAN 20 subnet because you have a router here. There is a layer 3 device that is attached to one of its ports of switch, and the router, as we know, doesn't forward broadcast traffic. So the broadcast traffic gets restricted in that particular VLAN itself. VLAN 10's broadcast is restricted to VLAN 10. VLAN 20's broadcast is restricted to VLAN 20. Okay. So the broadcast cannot be forwarded to other VLANs because of this router. So that is the advantage. And also we can implement security policy on routers. As we know, we can implement ACL, access control list, also on router to prevent traffic from going from one VLAN to other VLAN. So we are logically segmenting the LAN into different broadcast domains, not physical but logical. So VLANs and logically segment users in different subnets that I have already discussed with you means broadcast domains. And this is a logical segmentation and not a physical one. Users on different floors of the same building or even in different buildings can now belong to the same VLAN. Yes, it can happen. Means that the VLANs can span across geographical boundaries. So there may be that there is a building and on each floor you create a separate VLAN. There is a 10-story building and on every floor you create separate VLANs on separate switches. It can happen. And also the VLANs can span across geographical boundaries. One switch may be in Kolkata and another switch may be in some other cities like Bangalore and Delhi. It can happen. Just there is a picture there that is describing it as LAN versus VLAN. Say, by using switches, we can assign computer on different floors to VLAN 1, VLAN 2, and VLAN 3. You can see on each of the floors, we have different VLANs connected to different catalyst switches. Now, logically, a department is spread across 3 floors, even though they are physically located on different floors. Definitely. So the VLANs are spread across the different floors. So we can say that we have segmented the broadcast domain. On each floor, there is one broadcast domain. Okay. So there is another picture of the same thing. On floor 1, there is a catalyst 5000 switches on each floor. And floor 2, there are 3 pieces. And floor 4, 3, also there are 3 pieces. And also these three pieces belong to engineering VLAN. These pieces belong to marketing VLAN. These 3 belong to accounting VLAN. And they are spread across the floors. And you have a Cisco router also in order to communicate between the VLANs or the inter-VLAN communication. So the VLANs are situated on different floors. All the PCs, they're not on the same floor, but the VLAN members, PC belonging to different VLANs are on every floor. So that is the advantage of the VLAN, that it spans across the geographical locations. Now, I'm going to talk about static VLANs, that is a port-based VLANs. Static membership VLANs are called port-based VLANs or port membership-based VLANs. So what we do, we assign PCs to the particular ports of the switch. Now, VLAN 1 is called the native VLAN or the default VLAN or the management VLAN. We cannot use that default VLAN. It is used for management purpose for assigning IP address and default gateways related stuffs to the switch. We can configure other VLANs. So it is configured VLAN 10 or we can configure any VLAN to the ports of any switch. So that is the concept of static VLAN that I have already discussed with you. So now, after completing the theory part, I'm going to show you how to configure the VLAN using Cisco Packet Tracer. And I'm going to show you the Inter-VLAN routing. So here, I'm taking a switch, the Cisco Catalyst 2960 series switch. Okay. And I'm taking 2 devices, 2 pieces. You can take 2 laptops or 2 desktop, whatever you want. And you have to take a router. I'm taking a PT router. And you just connect, say, through straight cable, Ether by 1, passing 0 by 2, and this would be the trunk port F0 by 3 to the router. So first, I have to create VLANs on switch and then I have to assign the VLAN to the switch port. VLAN, say for example, VLAN Q, name sales, VLAN 3, name marketing, you can give any name. So these VLANs have been created, VLAN 2 and VLAN 3. Now you have to assign the VLAN to the port on which port? F0 by 1 and on F0 by 2. So just assign it interface F0 by 1 switch port access VLAN 2 and interface F0 by 2 switch port access VLAN 3. So we have assigned VLAN to the switch port F0 by 1 and VLAN 3 to switch port F0 by 2, and you make the port trunk the F0 by 3 that is connected to the router by giving the command switch port mode trunk. That's it. And now I have to go to the interface VLAN 1 to the switch. Give node chart to bring the interface up and give the IP address to the switch, because now the switch will communicate to the router. So the IP address is 192.168.10.1. Give the default mask, and then the default gateway should be assigned. Default gateway will be what? Default gateway will be the router's Ethernet port address. The default gateway, say it will be 192.168.10.10. So this IP address should be assigned to the router's Ethernet port. We have actually created the VLANs. We have assigned the VLAN 2 and VLAN 3 to its respective ports. We have made the connection to the router trunk, and we have also given the IP address to the switch as 10.1 and the default gateway as 10.10. So that is done in the switch. You save this, giving copy and start. Now you go to the router. Now on router's physical port, you shouldn't give any IP address. Just make the port up. Yes. And now you should create sub interface for VLANs. See, I'm getting first sub interface F0 by 0.1 and give encapsulation dot 1q space 1. There is an encapsulation method. There are two methods, ISL and dot 1q, and this router is taking dot 1q. IP address, there is a IP address would be the switch's default gateway IP, means 192.168.10.10. Now the second sub interface is 0.2 encap dot 1q 2, means 2 means for VLAN 2. The VLAN 2's gateway would be, the address would be 20, say 20.10, and dot 3 sub interface for VLAN 3 encapsulation dot 123, and the VLAN 3's gateway for PCs would be say 30.10. So you have actually assigned the gateway for the VLAN 2 as 20.10 and gateway for the VLAN 3 as 30.10. Save this configuration. And now to verify, finally, say that all links are up. Now this PC belongs to the VLAN 2 and this to the VLAN 3. So go to the laptop, desktop and IP configuration. Give the IP address as 192.168, say 20.100, default mask and default gateway as 192.168.20.10. And this is 192.168.30.100. Default gateway will be 192.168.30.10. Now this belongs to the VLAN 2 and this belongs to the VLAN 3. Now these two pieces should be able to communicate within themselves using this router. So that means we have to do the inter-VLAN communication. So just go to the command prompt, check the IP address is 20.100, ping the other PC, Yes, it's pinging. And check from the other PC also. 20.100, ping the 20.100. You just go to the simulation mode. First, you send the traffic, send a PDU from this to this, and it's successful. And from this laptop also is successful. Go to simulation mode and click on auto capture play. See, these two traffics, these two packets are forwarded to the switch from the laptop, and then they are forwarded to the router. So every packet is forwarded to the router. In case of the Inter-VLAN routing, the router again sends it back to the switch, and then the switch forwards it to its respective destination. So every communication is happening through router. Say every time it's going to switch, then router again it's coming back to the switch and then to its destination. So you can view the communication between the VLANs using this simulation mode. So this is about the inter-VLAN communication, a simple inter-VLAN communication that I've discussed with you. I hope it was informative to you. You have enjoyed it. And that's it for today about the VLANs. And on some other day, we'll come with some other topics. So for that time, it's goodbye.